The Pedia. General Studies Video Lectures. Notes and practice question sets for engineering service examination, and other UPS-conducted examinations. In this video we had discussed a subtopic of energy and environment, which is climate change. Let's start with some introduction of climate change. Introduction. The long-term average of a region's weather events. The phrase climate change represents a change in the long-term weather patterns. The measurable effects of the continual warming trend, usually measured in major shifts in temperature, rainfall, snow, and wind patterns lasting decades or more. Global warming. An average increase in the temperature of the atmosphere near the Earth's surface and in the troposphere, which can contribute to changes in global climate patterns. Greenhouse effect. The greenhouse effect is a naturally occurring phenomenon that blankets the Earth's lower atmosphere and warms it, maintaining the temperature suitable for living things to survive. Water vapor and greenhouse gases warms the Earth. Incoming energy. The Sun emits energy that is transmitted to Earth. Because the Sun is very hot, the energy is emitted in high-energy short wavelengths that penetrate the Earth's atmosphere. Absorption. About 30% of the Sun's energy is reflected directly back into space by the atmosphere, clouds, and surface of the Earth. The rest of the Sun's energy is absorbed into the Earth's system. 70%. Emission. The Earth re-emits energy back into the atmosphere. Because the Earth is cooler than the Sun, the energy is emitted in the form of infrared radiation, at wavelengths longer than the incoming solar energy. Role of greenhouse gases. Greenhouse gases in the atmosphere absorb much of the long-wave energy infrared radiation emitted from the Earth's surface. The greenhouse gases then re-emit this energy in all directions, warming the Earth's surface and the lower atmosphere. Greenhouse gases. Greenhouse gases means those gaseous constituents of the atmosphere, both natural and anthropogenic, those absorbs and re-emit infrared radiation. 1. Water vapor. The biggest overall contributor to the greenhouse effect, and humans are not directly responsible for emitting this gas in quantities sufficient to change its concentration in the atmosphere. CO2 and other greenhouse gases is increasing the amount of water vapor in the air by boosting the rate of evaporation. 2. Carbon dioxide. The main sources: I. The combustion of fossil fuels to generate electricity. 2. The combustion of fossil fuels such as gasoline and diesel used for transportation. 3. Many industrial processes emit CO2 through fossil fuel combustion. 4. Several processes also produce CO2 emissions through chemical reactions that do not involve combustion. Reducing carbon dioxide emissions. The most effective way to reduce carbon dioxide (CO2) emissions is to reduce fossil fuel consumption. Other strategies include energy efficiency, energy conservation, carbon capture, and sequestration. 3. Methane. CH4 is emitted by natural sources such as wetlands, as well as human activities, such as leakage from natural gas systems and the raising of livestock. Natural processes in soil and chemical reactions in the atmosphere help remove CH4 from the atmosphere. Human-induced. Agriculture. Domestic livestock such as cattle, buffalo, sheep, goats, and camels produce large amounts of CH4 as part of their normal digestive process. Globally, the agriculture sector is the primary source of CH4 emissions. Methane is the primary component of natural gas. Some amount of CH4 is emitted to the atmosphere during the production, processing, storage, transmission, and distribution of crude oil natural gas. 4. Nitrous oxide. N20 is naturally present in the atmosphere as part of the Earth's nitrogen cycle, and has a variety of natural sources. Natural emissions of N20 are mainly from bacteria breaking down nitrogen in soils and the oceans. Emitted when people add nitrogen to the soil through the use of synthetic fertilizers. Also emitted during the breakdown of nitrogen in livestock manure and urine, which contributed to 6% of N20 emissions in 2010. Emitted when transportation fuels are burned. Generated as a byproduct during the production of nitric acid, which is used to make synthetic commercial fertilizer, and in the production of adipic acid, which is used to make fibers, like nylon, and other synthetic products. Removed from the atmosphere when it is absorbed by certain types of bacteria or destroyed by ultraviolet radiation or chemical reactions. 5. Fluorinated gases. They are emitted through a variety of industrial processes such as aluminum and semiconductor manufacturing, substitution for ozone-depleting substances. Very high global warming potentials GWPs relative to other greenhouse gases. Well mixed in the atmosphere, spreading around the world after they're emitted. Removed from the atmosphere only when they are destroyed by sunlight in the far upper atmosphere. The most potent and longest-lasting type of greenhouse gases emitted by human activities. 1. Hydrofluorocarbons HFCs. 2. Perfluorocarbons PFCs. And 3. Sulfur hexafluoride SF6. Hydrofluorocarbons are used as refrigerants, aerosol propellants, solvents, and fire retardants. These chemicals were developed as a replacement for chlorofluorocarbons CFCs and hydrochlorofluorocarbons HCFCs because they do not deplete the stratospheric ozone layer. Unfortunately, HFCs are potent greenhouse gases with long atmospheric lifetimes and high GWPs. Perfluorocarbons are compounds produced as a byproduct of various industrial Processes associated with aluminum production in the manufacturing of semiconductors. Like HFCs, PFCs generally have long atmospheric lifetimes and high GWPs. Sulfur hexafluoride is used in magnesium processing and semiconductor manufacturing, as well as a tracer gas for leak detection. Sulfur hexafluoride is used in electrical transmission equipment, inducting circuit breakers. Black carbon, commonly known as soot, is a form of particulate air pollutant produced from incomplete combustion. Consists of pure carbon in several linked forms. A solid particle or aerosol, though not a gas, contributes to warming of the atmosphere. Biomass burning, cooking with solid fuels, diesel exhaust, etc., warms the earth by absorbing heat in the atmosphere and by reducing albedo, the ability to reflect sunlight when deposited on snow and ice. The strongest absorber of sunlight and heats the air directly. It darkens snowpacks and glaciers through deposition and leads to melting of ice and snow. Disrupts cloudiness and monsoon rainfall and accelerates melting of mountain glaciers such as the Hindu Kush Himalayan glaciers. Government measures. Project ESE has been launched to reduce black carbon in atmosphere by introducing efficient stove technologies, solar cookers, solar lamps and biogas plants. A ubiquitous and unidentified component of organic aerosol which has recently come into the forefront of atmospheric research. Light-absorbing organic matter other than soot in atmospheric aerosols of various origins, for example, soil humics, humate-like substances, ESE, tarry materials from combustion, bioaerosols. Climate forcings are factors in the climate system that either increase or decrease the effects to the climate system. Positive forcings such as excess greenhouse gases warm the earth. Negative forcings, such as the effects of most aerosols and volcanic eruptions, actually cool the earth. Natural forcings include changes in the amount of energy emitted by the sun, very slow variations in Earth's orbit, and volcanic eruptions. Human-induced forcings activities include greenhouse gas and aerosol emissions from burning fossil fuels and modifications of the land surface, such as deforestation. Greenhouse gases are a positive climate forcing, that is, they have a warming effect. Carbon dioxide emitted from the burning of fossil fuel is presently the largest single climate forcing agent, accounting for more than half of the total positive forcing since 1750. Burning fossil fuels adds aerosols to the atmosphere. Aerosols are tiny particles in the atmosphere composed of many things, including water, ice, ash, mineral dust, or acidic droplets. Aerosols can deflect the sun's energy and impact the formation and lifetime of clouds. Aerosols are a negative forcing. That is, they have a cooling effect. Estimate the effect of each gas. 3 main factors. 1. How much of these gases are in the atmosphere? 2. How long do they stay in the atmosphere? 3. How strongly do they impact global temperatures? Global warming potential. The global warming potential GWP for a gas is a measure of the total energy that a gas absorbs over a particular period of time, usually 100 years, compared to carbon dioxide. Gases with a higher GWP absorb more energy per pound than gases with a lower GWP, and thus contribute more to warming Earth. Methane CH4 has a GWP more than 20 times higher than CO2 for a 100-year time scale. Nitrous oxide N20 has a GWP 300 times that of CO2 for a 100-year time scale. Chlorofluorocarbons CFCS, hydrofluorocarbons HFCS, hydrochloro. Fluorocarbons HCFCS, perfluorocarbons PFCS, and sulfur hexafluoride SF6 are called high GWP. Global emissions by source. Energy supply 26%. Industry 19%. Land use change, and forestry 17%. Agriculture 14%. Transportation 13%. Waste and wastewater 3%. Next we will be discussed about a new topic of climate change, which is acidification.